Hi everyone, Mr. Markwick here. In today's video, I'm going to show you a method of constructing a number of constraints or inequalities based off a bit of information or a problem that you might be presented with. Now, this is one way of doing it. You don't necessarily have to use this process, but if it's a more complicated sort of situation, setting out a table might actually help. So let's look at the problem. Cabinet maker produces 2-drawer and 5-drawer filing cabinets. So they're the two products that are competing for our resources. The manufacturer has 34 drawers, 8 locks, and 42 meters squared of sheet metal available. So they're the three sets of resources that they're competing for. Number of drawers, number of locks, and the amount of sheet metal that's available. So the 2-drawer cabinets require obviously 2 drawers, 1 lock, and 2 meters squared of sheet metal. And the 5-drawer cabinets require obviously 1 lock, 4 meters squared of sheet metal, and 5 drawers. X is going to be the number of 2-drawer filing cabinets, and Y is going to be the number of 5-drawer filing cabinets. So I'm going to use that information, put it in this table here, and then hopefully that's going to help me easily create a set of constraints or inequalities. So first of all, our product is the 2-drawer filing cabinets and the 5-drawer filing cabinets. The number of 2-drawer cabinets is going to be represented by X, and the number of 5-drawer cabinets is going to be represented by the variable Y. And then we can look at our resources that they're competing for. So the first resource is obviously the number of drawers available. So for a 2-drawer filing cabinet, as we said, it's going to need 2 drawers. For a 5-drawer filing cabinet, we're going to need 5 drawers. And the problem tells us that there are 34 drawers available in total. Now, moving on to the next resource that we're competing for is the locks. So each of the 2 and 5-drawer cabinets will require 1 lock. And we said in the problem there are 8 locks available in total. And the final resource that we're competing for is the sheet metal. So the 2-drawer filing cabinet requires 2 meters squared, and 5-drawer cabinet requires 4 meters squared. And in total, there is 42 meters squared of sheet metal available. So this table is now going to help me write those constraints. I'm not going to graph these constraints or draw the feasible region. I'm just going to show you how to create the constraints or inequalities based on that problem. So essentially, I'm going to have 1, 2, 3 constraints. Let's start with the first one here in the drawers. So the number of 2-drawer cabinets plus the number of 5-drawer cabinets must be 2x plus 5y, 2 drawers for every 2-drawer cabinet and 5 drawers for every 5-drawer cabinet, must be less than or equal to 34. Okay, we can't go over 34 because there's only 34 drawers available. So that's our first inequality. The second inequality that we're looking at would be based on the number of locks. So 1 lock for 2-drawer cabinets, 1 lock for 5-drawer cabinets. So it was simply just 1x or x plus 1y or just y needs to be less than or equal to 8. And for the amount of metal available, our inequality will be, or our constraint will be 2x plus 4y is less than or equal to 42. So those are our 3 constraints or inequalities for that problem. Now, I'm also going to throw in an extra 2 because we can't have a negative number of cabinets being made. So I'm simply going to add in x needs to be greater than or equal to 0, and y also needs to be greater than or equal to 0. And that's it. The main problem would be how many constraints do I have to come up with? Well, again, it depends on the problem. In this case, I needed to add these extra 2 because I can't make a negative amount of a product. And I came up with 3 initial constraints because I had 3 resources that my 2 products were competing for. Okay, so that's just one method you can use when trying to construct some constraints or inequalities based off some information or a problem. Okay, thanks for watching.